Welcome and thank you for joining on another homework question. This time we have number 13 from lesson U5 L3A. Recall that in this lesson you were introduced to the dot product, which is a form of vector multiplication. So if we have two vectors A and B, we can find the product A dot B, which is equal to the magnitude of A times the magnitude of B times the cosine of the angle theta, where theta is angle made between A and B. So in this question, we are told that there are three vectors, A, B, and C. And the three vectors are connected to each other by this equation. So vector A equals B plus C. So we have to show that magnitude of A squared equals magnitude of B squared plus 2 times vector B dot vector C, and then plus magnitude of C squared. So we're going to start off with the information given. So what we are given is the vectors B plus C, so the sum of them would be equal to A. So since these two vectors are equal, so left and right side are the same, and that's a given, then if we multiply by the same number, then the equation will stay true. So I will dot product vector A with vector A, and I will dot product vector B plus C with vector B plus C. And again, as you can see here, multiplying by A or B plus C is the same thing because they are equal. I'm going to make this dot in here pronounced just to show that, this is a special symbol for the dot product, so it's a bigger dot. So according to the dot product formula, then we're going to say that A dot A would be the magnitude of A times the magnitude of A, and then times, so let's keep an eye on the dot product formula, cosine of angle theta, where angle theta is the angle that the two vectors will make with each other. Now remember that a vector will make an angle of 0 degrees with itself. So it makes sense to say that would be cosine of angle 0. So in the next, on the right side actually, we're going to dot product these vectors. So we are foiling. And remember, we have dot product here, so we're going to have B dot B first. So this would be these two vectors. And then plus, we have B dot C. So B dot C. And then plus C dot B. And then plus C dot C. So as you can see here, all these dots are dot products, right? So not ordinary multiplications. So on the left side, we have cosine of 0. Now cosine of 0 is equal to 1. So you can use a calculator if you wish. And this is a number, this is a number. So a number multiplying itself would be the number to the power of 2. So we'll say that we have vector A, magnitude of A to the power of 2. For B dot B, we'll do something similar that we did with vector A. So that means magnitude of B, cosine. Guess what again? Angle 0, because B makes an angle of 0 degrees with itself. Plus, and here we have to do a little bit of work. So you see how we have B dot C and C dot B? We have discussed that in dot product, the order doesn't matter because it's scalars, right? So if you dot product A with B, that's what you get. If you dot product B with A, then you will have magnitude of B, which is same number, positive number, magnitude of A, angle same, right? So the order doesn't matter. So what that means is that we can combine them together in a B dot C multiplication. And again, for vector C dot C, we'll have magnitude of C multiplied by the cosine that angle C makes with itself. And again, what angle does vectors or a vector make with itself? Angle 0. So we'll write 0 here. So the left side has the magnitude of A to the power of 2. The right side will have BB cosine 0. That will be the magnitude of B to the power of 2. And then plus, so 2 times B dot C will be 2 magnitude of B, magnitude of C, times the cosine of the angle made between B and C. And then c times c, cosine 0 will be c multiplying itself, multiplying 1, so that would be the magnitude of c squared. So therefore, we're going to say that the left side is magnitude of a squared and the right side is b squared and c squared. That's where we go. Then the middle is 2b dot c. Actually, we expanded it. You could have kept it in this format. Now, this is the answer for question A. So for question B, we have if vectors b and c are perpendicular, how does this prove the Pythagorean theorem? So that's fairly easy to figure out because all we have to do is make angle theta 90 degrees. So if angle theta is 90 degrees, then we'll say a squared would be equal to b squared plus 2 times magnitude of b times magnitude of c cosine of 90, which is equal to 0 practically, and then plus magnitude of c squared. So I wrote the step, but you can tell that it's not really necessary at this point. So we have magnitude of b squared plus 2 magnitude of b, magnitude of c, cosine of 0 is 0, and then plus c squared. So magnitude of a squared here. So this entire thing here would be equal to 0, right? So that means that the entire term will become 0, and we are left with magnitude of a squared equals b squared plus c squared. And as you can see here, this is the Pythagorean theorem that in a triangle you have one of the sides brought to the power of 2, that's the longest side, would be equal to the sum of the squares of the other two side lengths. So I hope that dot product starts making a little bit more sense, and I hope you found these instructions useful. Bye for now.